probably okay if it's this. It's probably not going to get you that bad on the exam. There'll be a question or two, maybe 3, maybe, possibly. But it shouldn't be too many of them. Whereas if you didn't know how to graph lines, you'd be in very big trouble. Or if you didn't know how to find the, well, they're not going to ask you just a straight Pythagorean theorem problem, I don't think. But distance, for sure, you're going to need to know how to do, probably. So you may use Pythagorean theorem for that. So there's a lot of the things, like if you don't know anything about quadratics, if you can't factor, then that's going to get you way worse than this. So a sequence is a list of numbers formed by a pattern. You've been doing this since you were little bitty, right? So in kindergarten, first grade, second grade, they started giving you patterns, right? 3, 5, 7, 9, 11. That is a sequence, right? It could be much easy. It can be very easy like that. It can be much more complicated, but it is a list of numbers that is formed by some sort of pattern. So what we have been doing pretty much in this class is we have been using what are called explicit formulas. Okay? Explicit in this case does not mean it's full of cuss words and that you shouldn't listen to it. It means it gives you exactly what you're looking for. Okay? So an explicit formula will give you any term in the sequence if you just plug in that number. So if I want to know the 5th number in the sequence, if I want to know the 5th number, then I would just plug in. N stands for the number of the sequence. So I just plug in 5 there. I do 3 times 5 plus 1. That'd give me 16, right? So the 5th number in this sequence is going to be 16. I can go straight to the 5th number. I don't have to find any other numbers. I don't have to find the 1st, 2nd, 3rd, 4th, 5th number. I can just go straight to the 5th number. So this is basically like what everything we have done with like graphing with x, y coordinates. So when you have a formula like y equals 3x plus 1, that's an explicit formula. We haven't used a sub n and n very much, but you can almost treat it like this is just y equals 3x plus 1. You have a number you plug in, it spits a number out. Okay? So that is the explicit formula. But what we're going to be looking at today is a recursive formula. Okay? What does the beginning of that word recursive sound like? What? A little bit. Recur. Something that is recurring does what?
It comes back.
Happens over and over and over and over again, right? So a recursive formula is a formula that gives you a number based on the number that was before it. So, for example, a sub n equals a sub n minus 1 plus 5. Now, one thing, we used to have these awful, terrible textbooks called the Core Plus books that they made us buy, and it was just like paragraphs and paragraphs and paragraphs of reading and all these application problems with no examples, and it was so difficult to teach from them, and I did not like them. I've still got them in the closet, but I hardly ever use them anymore. The one thing that I do like from, there's 2 things I like from that book. All my pumpkin chunking stuff came from that book. And I do like that, so I keep using that, although I have kind of rewritten it myself instead of using the stuff from the book because it's kind of wordy. The other thing that I like is they don't do recursive formulas like this. What they do is they say a sub n equals next, and they say this right here equals now. You guys remember that one problem on one of the homeworks I gave you. I told you just to skip it and not worry about it because it was something we had not done, but it had a next and a now in it. You guys remember seeing that? So a sub n, if I want to find the next number, I take what I've got now and I add 5. Okay, so like let's say that I knew that a sub 1, which this just means when I have an a with a little 1 behind it, that just means the first term, or the first number. Let's say that that equals 7 for this. Okay, so if a sub 1 is 7, if I want to find the second term, my formula here is just telling me to take what I have now and add 5 to it. So I've got 7. I'm going to add 5 more. So 7 plus 5 will give me 12. If I want to know the next term, I would do 12 plus 5. Take what I've got now, which is now 12, add 5 to it. That would give me 17. What would the next term be? 22. And then you would just keep doing that. So this is, rather than giving you the number that, like if I plug in 4, it gives me 22. I have to find all the numbers that lead up to it. Right, so I would have to just, it's telling me what the pattern is really to my sequence there. Does that make sense? The reason they use this, notation where we got a sub n equals a sub n minus 1 plus 5. Let's say that we're looking for a sub 4, right, the fourth term. So that means my n equals 4. So if n equals 4, then this would be 4 minus 1 plus 5. And what is 4 minus 1? A sub 3. Right? So if you're looking for a sub 4, you take this n minus 1, take the one before it, which will be 3, and add 5 to it. That's what the notation means. Or you can kind of, I like this thinking of it as the next number equals what you have now plus 5. For that. I think that makes more sense, is a little easier to follow. We used to have to do recursive formulas more, but we could use the next now notation because they put it on the test like that, and I liked that better because kids could follow that actually pretty well. Okay, so let's talk about some things that they may possibly ask you here. All right, so these questions say for each recursive formula, find the fourth term, which would be a sub 4. Okay, so what they've given us is they've given us a recursive formula, and then notice you got that semicolon right there, and they gave you a term to start from, because recursive formulas are not really any good unless you know like where to start at. Because you might know your pattern is to add 5 each time, but you don't know what number to start at unless it's given to you. So we know it's already given to us that a sub 1 equals 9. So if we're thinking right here, this is really like the next number equals this right here, this part right here. That's like what we've got now, minus 4. Okay, so if my rule is to take what I've got now and subtract 4, what would a sub 2 be? 5. Very good. What would the next one? What would a sub 3 be? 1. And then what would a sub 4 be? Negative 3. And so that would be our answer for this one. The idea is not very hard. It's just a pattern, right? So, you know, if I told you that the first number's 9 and the pattern is to subtract 4, what are the next numbers, you could have probably done that pretty easily. It's the notation that a lot of times really makes it difficult for students to see what's going on here. Okay, questions? All right, here's our next one. All right, that a sub n, that's our next. So the next number, what do we do to find the next number? Right, so it's 5 and it's right next to that, so that means it's multiplied. So 5 times what we have now, right? That a sub n minus 1 is your now. Okay, so our pattern is to take whatever we've got right now and multiply it by 5. So this time, notice they didn't give us a sub 1, they gave us a sub 0. Basically just means we're starting like 1 behind where we were. So the next one would be a sub 1. What would we get? Negative 10. We just multiply that by 5. All right, a sub 2 would be negative 50. A sub 3. Not 100. We got to multiply by 5. So 50, it's going to be negative 250. And then a sub 4. We're going to multiply by 5 again. We'll get negative 1250. That would be our answer. Okay, everybody okay there? All right, who thinks they can tell me what the recursive formula is for the second one using like next equals? Aiden, go ahead and tell me what it would be, the recursive formula. Next would equal... that would give you the next term. Like if I'm just trying to write this as a formula, this right here is our next equals, what would it be, Savannah? 7 plus what you have right now. So right now we got a sub 2 equals 4. So the next number, we would do 4 plus 7 like Aiden said, right? And that would give us 11. And then for the fourth term, we'd have to do 7 plus 11, 18. And so 18 would be our answer there. Okay, questions? Okay, a couple terms. I don't know if you'll see these on the exam, but we're going to throw them in here anyway. I know they definitely sometimes show up on ACT. You got arithmetic sequences and geometric sequences. Arithmetic sequences are a sequence formed by adding a set number to the prior term. So out of the 3 examples that we just did on above, which one of those would be an arithmetic sequence? Okay, 3 is. There's another one. How is 1 1? Okay, because I only wrote adding. But can you add negative 4? You could. So really, I wrote the word adding here, but it sometimes looks like subtracting if your number is negative. You're right. You could get away with like never subtracting theoretically by always just like adding a negative instead. Although you got to understand subtraction to be able to do that.
The geometric be multiplying?
It's multiplying. Yes. And so multiplying looks like example 2. It also sometimes looks like division, because if you are multiplying by 1/2, that's the same as dividing by 2. So sometimes your adding actually looks like subtracting. Sometimes your multiplying actually looks like dividing. There. So it's called arithmetic if you're adding. It's called geometric if you're multiplying. I don't know that you'll see that, but I'm going to throw it in here while we're doing this just in case. So arithmetic, which remember is adding, recursive formulas correspond to a linear explicit equation. That should make sense because in a linear pattern, right, you have a constant rate of change. You're adding the same amount each time. When we look at tables, our table's going to like maybe be going up by 5 each time. It's the same amount added each time. So if you have a recursive formula where you're adding or subtracting, then that is going to be linear if you were to graph it. And your explicit equation is going to be linear. Okay. Geometric recursive formulas are going to correspond to an exponential. Explicit equation. This is going to be important because I'm going to show you how you can kind of use Desmos to help you out on this, but you need to know whether you're trying to make a line or a curve out of it, because if you don't get that right, it's going to be more difficult. We could kind of like memorize something for this next part, but I'm going to show you what I would do instead. Because if you memorize it, if you can memorize it, that's fine and great, as long as you can memorize it and keep it in your mind until the exam and beyond. But I find a lot of students get mixed up and can't remember it. So let's think about what we've got here. And rather, it asks us to write an explicit formula. Okay? So I'm going to do this one for you and show. That means we need to write it where it's not like we just, because this just tells us like the next term, right? We want it to where if we want to know the 17th term, we can find it really easily. So like, if we look at this, this tells me that my next number in the sequence equals what I have now minus 3. Okay, really quickly, I want you to find, well, as quickly as you can, I want you to find a sub 17 for me for this sequence. A sub 17. I guess I should find it quick too. Alright, so find a sub 17. Alright, anybody think they got it? Alright, Evan? Nope. I think you're right. Okay. Now, if you're going to do this, with recursive formulas, you got to go a sub 0 is 5, and then what would a sub 1 be? 2, and then a sub 2 would be negative 1, and then a sub 3 would be negative 4. And so, like, this is going to take a very long time if you got to find a sub 17. A sub 3 or 4, it's not that bad to do. But a sub 17, it's going to take forever. Okay? That's why we like to have an explicit formula. Caitlin? Okay, let's talk about we're going to talk about how that works with like the explicit formula we're going to come up with, because that is correct. So, let's do this. This will work no matter what. See how I have these numbers right here? Let's make a table out of them. So like I had a 0 here, and then I had a 5. I got a 1 here, and I got 2. I got my base was 2 here, I got negative 1. 3 here, I got negative 4. Let's make a table out of this. Okay, so if I have a table, and hopefully this will show up on the calculator active section because that ruins what I'm going to tell you how to do if it doesn't. If I type it in, alright, that is going to put these right here. Alright, I can see those points. You should, in most cases, be able to tell it looks like a line. Right, this looks like a line. So, we can do y sub 1 squiggle mx1 plus b, and it'll find the equation of the line for us. Or that one in particular, we could find that one by hand if we needed to, right? Because it just has a slope of 3, negative 3, and then it has a y-intercept of 5. Okay, so the equation for this, it's y equals negative 3x plus 5. But you're not going to see it written like that. You're going to see it written like this. A sub n equals negative 3n plus 5. In this case, your y is the a sub n and the x is an n instead. When they're using this type of notation, they'll use that instead. Now, if we look at what Caitlin said she did, she said she took 3, right? She multiplied it by 17, which is what our formula tells us to do, right? And then since that's negative, she's subtracting it from 5. So this formula is doing exactly what Caitlin realized she could do to shortcut this because she didn't want to go minus 3, minus 3, minus 3, minus 3, minus 3 a bunch of times, right? So, so she was jumping to this formula as a shortcut for that. Okay. The reason I like this table method is because it is true, like this number you're multiplying, you're subtracting right here, it's always going to be your slope. And as long as you have a sub 0, that is going to be your y-intercept. You could memorize those things, but sometimes you don't have the information like that, and sometimes it's not adding or subtracting. So I like doing a table because it's a little bit more foolproof for that. But lots of ways you can approach these. Okay, so this would be your answer there. And hopefully these are also multiple choice where you could like maybe graph your answer choices and try. Notice whenever you see them, if you see answer choices where you got like an a sub n and an n, I don't think that Desmos will graph that. Let's try. It won't even type in a sub n. Yeah, you just need to change it to a y and an x for that so that it can graph it there. Okay, questions on that one? All right, let's try another one. Let's try the same strategy, okay? So first of all, let's think about what this equation is telling me to do. So that a sub n is always what you're looking, your next number in the list is going to equal 0.5 times what you got right now. Mm-hmm. Does it graph it? You gotta go to the table. Shift, what is it? Oh, and go change it. Let's see if it graphs it. Oh, it does graph it. I think there's also, is it like shift underscore? Yeah, shift underscore. If you do that, that'll go to the base. Wonder if there's a way to type it in. If it doesn't really do it there. Yeah, if you do shift underscore, it'll do a sub n. So it will graph it. So you can type these in if you can remember how to do that whenever we get there. So that's good to know. Wonder. A sub n equals 0.5 times a sub n minus 1. We gotta have that. We need that minus 1 down there in the bottom. I don't know if it'll do it or not. A sub 0 equals a. I don't think that works. Even though it is 80, so let's zoom out. Let's zoom out and make sure it's not there. I don't think so. No, it's not. It won't graph recursive. I was really thinking we might have found a loophole if that was the case, but it will graph that answer to see if it fits your points. So that can be helpful. So let's do like we did on the last problem. Okay, we got a sub 0 is 80. So the next number, to get the next number, we take 0.5 and we multiply what we've got by right now. What would we get for that? 40. And then the next one would be 20. And then the next one would be 10. And then the next one would be 5. And let's stop there because we're going to get into some decimals after that. And I think this will be plenty of points for us. So if we go over here, put this in table 0, and then go over here, 80, 40, 20, 10, 5. Okay, does that look like a line? It looks pretty curved to me, right? So, and that's one reason we wrote this up here. If you're multiplying by a number each time, it should be exponential. So if we do y1 squiggle a times b to the x1 power, it is going to give us an exponential. And we are getting a is 80, b is 0.5. So that's going to be, if we use it with x's and y's, that's 80 times 0.5 to the x power, but they're going to do n, a sub n equals 80 times 0.5 to the n power. And you can test this by like plugging in some numbers. If we do 80 times 0.5 to the third power, you see we get 10, which is what we were supposed to get. Or if we do to the fourth power, we're going to get 5, which is what we were supposed to get. Now notice 80 is this number here. The 0.5 goes here. That's always going to be the case as long as they give you a sub 0, but sometimes they don't for that. Okay, questions there? All right, let's do a couple more things. Now, this is similar, but it's a little bit different. So let's talk about this one. This is what we got coming up next is going to equal what we have right now plus 2. They don't give us a sub 0, they give us a sub 1. So we're going to say 1 is 4. What would the next number be? 6. What would the next number be? 8. What would the next number be? 10. That's probably enough. You just need a few numbers there. So if I go over here and put this in a table, 1, 2, and I'm using Desmos on all of these, but especially these with small numbers, if it did show up on calculator inactive, you could graph these on your graph paper and do this by hand fairly easily. All right, so in fact, let's try to do this by hand. And then we'll check. What's the slope of that line? 2. So that's y equals 2x. All right. What? I can't see the y-intercept, but what do you guys think it's going to be?
3. Wait, no.
3 is a little too much. 2. There, 2x plus 2. So that's using x's and y's. They are going to write it with a sub n equals 2n plus 2. Notice that this number right here was still the slope of the graph, but this time this number we had was not our y-intercept. That's because it was a sub 1 instead of a sub 0. Everybody okay there? All right, let's do a table for the next one. It tells me the a sub 1 is 5. Isabella, what are we doing in this rule? What does that rule, recursive equation, tell me to do? Multiply by 2, right? Because this right here is what we're looking for. Our next number will equal 2 times this right here is what we got now. So we're multiplying by 2. So the next number in this list, what's it going to be, Isabella? 10. Then after that. And then after that. Good. And that's probably going to be good enough. And so I can't even see this very well, but if we go over here. Oh yeah, let's do that. I forget about that. Lived so much of my life without knowing how to do that I still forget. All right, so is this linear? It is not. It looks exponential. So exponential, you're probably less likely to be able to guess that one, right? So I would just go straight to y1 squiggle a times b to the x1 power. There's our line. Our a is 2.5, and our b is 2. And instead of doing x power, we'll do n power. We'll call this a sub n equals. Okay, let's look at a couple more types of questions that they might give you. And then we'll kind of be done with this and move on with our lives. Maybe some of you understand it well. Maybe some of you don't understand it that well. We'll probably still be able to live long, happy lives either way. So, yeah, hopefully. Let's just say this. If we don't, I don't think it's going to be because we didn't understand this today. So, which of the following recursive equations corresponds to the explicit equation a sub n equals 2n minus 5? Okay? What do you think, Aiden?
It could be C or D.
Okay, why not?
Because the y-intercept is -5.
Okay, so that a sub 0 ends up being your y-intercept, right? Like your 0 term is 2 in that case. And this y-intercept is 5. So we could go ahead and throw these two out if we recognize that from the beginning. Okay? Then what do you think, Aiden?
It's not exponential, so
Okay, so this is not exponential, it's linear. If you're multiplying, that makes it exponential. Adding, like you see on B, is going to be the correct one. So you could do this whole thing without graphing or looking at a thing. But let's say maybe that you have forgotten lots of things that I had taught you very quickly on this day. So let's just look at a couple other ways you could approach this. Let's do like Evan showed us and type this in, a sub n. I'm doing shift underscore and it takes me down there. Or you could do, like, you know when we type in like x1 or y1, if we put a 1 there, and then we go back down there and tell it to be n instead and get rid of the 1, that'll also work. So a sub n equals 2n minus 5. So I'm going to type in that equation. Let's hit the house button. All right, so there, it'll graph it for me. All right, here's something that you can do for this. Look at A, right? I'm going to add a table. All right, so a sub 0 is -5. So I'm going to put that in my table. All right, then this rule for A tells me to multiply by 2. So the next number, if I multiplied by 2, would be -10. And then the next number would be -20. Is that anywhere close to fitting the line that we're looking for? No. So that's out. So then we'll start again. Okay? So we would still start with -5 here. If I add 2 to my -5, I'd get -3. This is looking good. Then -1. Then the next term would be 1. And all of those fall on that line, so that lets me know we're okay there. Whereas if I did C and D, if I just go show you real quick what they start off looking like, a sub 0 is 2. If I graph it, that's not on the line. So if you got any points that don't fall on that line, you know it's wrong there. Okay, what do you guys think about this next one? Which of the following formulas corresponds to the equation given by a sub n equals 8 times 1.5 to the n power? Okay, first of all, is that linear or exponential? Exponential. So
Get rid of C and D.
we can take out C and D because those are adding. Adding is going to be linear. All right, what do you think? Aiden?
I think it's A because it says A1 equals 12, what makes like A is multiplied by 1.5.
Okay. So that would be, I hope there's a right answer to this. Yeah, there is. I think, yeah. So if we multiply by 1.5, 8 times 1.5, we would get 12. And you can also do that, like, if you just plug in 1, right? 8 times 1.5 to the first power, that should give you a sub 1, which is going to be 12 there instead of 8, so that's good. You could also do like we did on the last problem, a sub n equals a sub n equals 8 times 1.5 to the n power. It's going to graph it for you. You can make yourself a table. You don't really have anything for 0. You could do 12. And if you multiply it by 1.5, 12 times 1.5 is going to give you 18. Then you can multiply by 1.5 again. And you can't really see this, but you get 27. And then those fall on the line. So that lets you know that that is good if you're double checking. So that would, A would be your answer there. Questions on that? All right. Try this last one. I want you to try it on your own. See what you can do with it.